All right, this is on unit vectors. The definition of a unit vector is a vector whose magnitude or length is a distance of 1. In application problems later on in our book, we're going to be using unit vectors. So to find the unit vector that has the same direction as a non-zero vector, we're going to be using this equation here. So the unit vector is taking the vector and dividing it by its magnitude, the length of that vector. So here's an example. Example 7. Find the unit vector in the same direction as vector v, which is 5i minus 12j, and then verify that it has a magnitude, a length of 1. So we first need to find out what is the magnitude of this vector. So I just want to take a minute just to say, what does this vector look like graphically? So if here is your coordinate plane, remember this is your A value and this is your B value. You're moving right 5 and then down 12. So this vector looks like that. Okay, and what we want to do is find out what is the length of this vector. So the notation of length or magnitude is the double vertical line. So step 1, we want to find the magnitude. How long this vector is. So to do that, we've done that earlier in our lessons. The equation is the square root of a squared plus b squared. So this is our a value, and this is our b value, and we're going to substitute it in. So 5 squared plus negative 12 squared. Simplify it. 5 times 5 or 5 squared is 25. Negative 12 times negative 12 is 144. Add 25 plus 144 is the square root of 169. And then simplify it, and you get 13. So what we found is the length of that vector, starting at the origin and finishing at 5, negative 12. All right. Once we know that magnitude, we can now use our equation on the previous slide. We're going to take the vector and divide it by the magnitude. So number 2, step 2, we're going to take the vector and divide it by the magnitude. So the vector is up here in the green that I had circled before. So that's 5i minus 12j. And you're going to divide it by the magnitude, the length, 13. So to simplify this, we break it into 2 terms. So we're going to take 5i divided by 13 minus 12 divided by 13j. So now that is our vector as a unit vector. Part 3 says, now verify that that vector is a length of 1, a magnitude of 1. So number 3, verify the length is 1. So in step 2, our new vector as a unit vector is now 5/13 I minus 12/13 j. Graphically, what it does is it takes this blue vector and shrinks it down to a length of 1, going in the same direction. So we want to show, does this vector actually have the length of 1? So we're going to use the same formula to find the magnitude. You square root your a squared and your b squared and add them together. So this is my a value for my unit vector, and this is my b value for my unit vector. So we're going to go ahead and substitute in that black equation. So the magnitude of this unit vector is 5/13 squared plus negative 12/13 squared. So 5/13 is 5/13 times 5/13. Which is 25 over 169, plus negative 12/13 times negative 12/13 is 144 over 169. Combine those fractions together, you're going to get 169 divided by 169, which reduces to the square root of 1, which is 1. So the length of that unit vector that I put right up on here, this length is a distance of 1. The original vector was a length of 13. You're just shortening that vector up when you have a unit vector.